Okay, so for this experiment, you're gonna need this page that says Osmosis Experiment. Print that one off, or at least have it available to look at while we're going over this lab. We are gonna fill in the first two columns, and then you're gonna fill in the third column, and you're gonna need to complete this in eLearn as a quiz, but it'll be a homework grade. The last column we are not gonna use, okay? So make sure you have this paper available. We're gonna go through those steps right now. I've already started to set up this lab because it takes about, well, if you're in the classroom, it takes about an hour. So I've already set up the first 3 bags. So the bag number 1 has distilled water. Bag number 2 has 10% sucrose. Bag number 3 has 30% sucrose. And we're gonna make bag number 4, which also is gonna have distilled water. I just kind of wanted to show you how I made those. This is dialysis tubing, and you put it in water for it to come apart. It'll open up. And so I have our solutions here. I have water, and then I have 10% sucrose and 30% sucrose. The directions say to use a graduated cylinder, but since I'm at home, if you're a mom or a dad, you probably have 1 or 10 of these in your house if you have kids. So we're gonna pull up 10 mLs of distilled water and open up that tube just enough to get the tip in there, and then I'm just slowly gonna add the water. Notice that I've already tied off one end of the dialysis tubing, and after I add the 10 mLs, I'll take the tube and just gently twist the top so that I don't lose any water. And then I'm gonna tie off this end, okay? So give me just a second to tie this off. Okay, so this has been tied off, and I'm just gonna snip off the ends, and there is bag number 4. Okay, so let's just go over it one more time. Bag number 1 is distilled water. Bag number 2 is 10% sucrose. Bag number 3, 30% sucrose. Bag number 4 is distilled water. And so the first column, we're gonna weigh each of these, and I would like for you also to record these weights as we go through them. We're at 0 on our scale, well, except I touched it. Okay, now. Okay, the first bag weighs 9.5 grams. Bag number 2 weighs 10.2. Bag number 3 weighs 11.1. And bag number 4 is 9.8. Okay, so I can set my scale over here. I'm gonna slip the bags out of the way for just 1 second. Now, each one of the squares on your chart says that we're supposed to put these in beakers. Well, we're gonna improvise and use little cups. This is exactly the same experiment that we do at Chattanooga State. So here's beaker 1. Inside of beaker 1, we are supposed to have distilled water. Okay, so here's my water. I'm gonna put that in there to the fill line. Okay. Beaker number 2 also has distilled water. Beaker number 3, distilled water. Beaker number 4 has 30% sucrose, okay? So I'm gonna need to make sure I'm using 30% sucrose and put that to the fill line. There we go. All right. So all of our bags are ready and they've been weighed. Our beakers are ready. Make sure you have a timer close by. And I'm gonna set it for 1 hour. We're gonna leave it in here for 1 hour. So bag number 1 in beaker number 1, bag number 2 here, 3, 4, push start. All right, so those need to sit for 1 hour. We just need to make sure that they are all under the solution that they are sitting in order for this experiment to work. Okay. Okay, so while our cells are in the beakers, I just want to go over something that I would typically draw on the board if we were in the classroom, and that's tonicity. I want to talk about hypertonic and hypotonic and the reason why we're doing this lab. So the little bags that we prepared represent the cells, and the solution that's in the beaker represent the fluid that's around the cell. So this is just like a blood vessel, and here are some cells in your blood vessel, and then the fluid around the cells would be the liquid that's in the beaker. So a hypertonic solution means that the solute concentration outside of the cell is greater than what's inside the cell. So in this blood vessel, the cell is 0.9% solute, and what's outside the cell is a 10% solute. In a hypertonic situation, the cell will shrink, or crenate is another term for that. In a hypotonic situation, the solute concentration is lower than, less than, what's inside the cell. So in each blood cell here we have 0.9%, and then outside of the cell in our blood vessel we have 0.2% in this particular example. In a hypotonic solution, the cell will swell, burst, and lyse. Now this is something else that I would draw, because these represent the bags. This cell is 0.9% in each one, and I've drawn a hypertonic situation here and a hypotonic here. And so just pay attention to the percentages. This number represents the solute. So this is 0.9% inside the cell and a 10% solute concentration outside the cell. And the reason why the hypertonic cell is going to shrink or crenate is because it is trying to concentrate everything that it already has. So it's trying to go from 0.9 to 10 by releasing water and shrinking what it already has. And the exact opposite happens in hypotonic. This 0.9 is trying to reach the equilibrium of what's outside at 0.2. So it's going to take on water to try to dilute what it already has. So it will take on water. Water goes this way in this example, and water goes that way in this example. So in the hypotonic solution, the cell takes on water, will swell and burst. Hypertonic, the cell will release water, shrink, and crenate. And before our experiment is over, why don't you just go down through here and predict what you think is going to happen with each one of these bags based on what we just went over in tonicity, hypertonic and hypotonic solutions. Okay? Okay, so my timer just went off, and we're going to take the bags out of the cups. And so what I'll do is I'll take bag number 1, and I just want to keep track of them by putting them by the correct thing on my paper towel. Okay, there's bag number 2, 3, and 4. All right, and I'm gonna get my scale, and I am just gonna tap these dry just a little bit. Okay. All right, here we go. Get ready to record some weights. Here is bag number 1. Okay, bag number 1 weighs 9.6. Okay. Bag number 2 weighs 11.7. Bag number 3 is about to burst. All right, it weighs 14.6. Bag number 4 is 6.0. Okay. All right, so I'm going to show you what to do with these numbers, and I'm going to use an example of numbers that we did not see, because these numbers that you recorded here are going to be your homework. And the third column, you're going to enter those numbers, the percent change, in a quiz that's in eLearn. So the initial mass is the first column. The final mass is what we just did. So in this example, the initial mass 9.6, the final mass 13.0. Please use the equation that's right here on your paper to find the percent change. Get your calculator handy. And then we take the final mass, subtract the initial mass, divide by the initial mass, and then multiply times 100 to get the percentage of the change. Please do that for number 1, 2, 3, and 4. And let me know if you have any questions.